Good morning, my dear students. For class 12, today is 30th September 2020. In this class, we'll see derivation of Lensmaker's formula and formula to be remembered. The first one is refraction through a spherical surface when the object lies in the rarer medium. And I do believe you will still remember the formula. The formula is minus mu1 by u plus mu2 by v is equal to mu2 minus mu1 by r. And the second formula that we have derived, that is refraction through a spherical surface when object lies in the denser medium. In this situation, we just happen to interchange these two only, keeping other quantities the same. So we can write minus mu2 by u plus mu1 by v is equal to mu1 minus mu2 by r. These two formulas are to be used in the derivation. So to start a derivation, let us see the diagram. This is supposed to be your lens, which is considered to be thin. Usually the lens should be thin. There is the object. It has two poles P1, P2. Let this be the axis of the lens. Say C be the center of the lens. Here is the ray that comes from the object, and you call it XY. So on the first surface XP1Y, this suffers refraction here. So image should be formed. Let's say this image is formed here, and you have another surface XP2Y. Because of XP2Y, you have one more image formed here. This is going to be I here. So object distance we write as U, usually taken from the center of the lens, and this is image. I dash is the image. So let us call it as V dash, and another image. So you can call it V. And if you drop two lines, one is perpendicular to the surface here. It's 90. This is normal, so it should be passing through the center of curvature. Similarly, if you draw another line here, this should be the normal. So it should be passing through the center of curvature. So let me call it C1, C2 here. Distance between this center of the lens and the first center of curvature is what? R1, radius of curvature. So similarly, distance between C2 and axis of the lens or center of the lens should be R2 here. And our lens is surrounded by a medium of referred index mu1, and the lens is made of a material like glass material with referred index of mu2 here. So this is your ray diagram. So in the first step, we're going to see the refraction through XP1Y. So here you can write refraction through XP1Y here. In this case, you apply the first formula, that is refraction through the spherical surface when object lies in the rarer medium. So if you use this one, you can put it here. Minus mu1 by u for the object distance, still always object distance is u again, followed by plus mu2 by v for the image distance. In our case, O is the object and here is the image here. So image distance is v dash is equal to mu2 minus mu1 by radius of curvature for this surface is on the other side, that is R1. Question number 1 here. And note that in this case, O is the object and this I dash is the image here. For which surface? XP2Y. The surface XP2Y. So this is our first equation. Then for the second step, now you talk about the refraction through, this time refraction through the right surface XP2Y xp2y here for this surface, xp2y. In this situation, IDS will be the object, IDS will be the object, and I will be the image here. So I will be the image. Okay. So if you apply the second formula, you have this minus mu2 by u for the object distance. In our case, IDS is the object, so object distance become VDS followed by plus mu1 by v for the image distance. Here is the object, here is the image, so image distance become v here. So you can write v, this is equal to mu1 minus mu2 by the radius of curvature for this surface would be r2 here. So you have got second equation here. So our next step is you just add up the two equations. Let us see what we get. So after adding the two equations, you just add up the left hand side here, left hand side, these two left hand side, you just add it up, plus you add up the right hand side also. Let me add it right now. You should get minus mu1 by u plus mu2 by v ds, then minus mu2 by v ds plus mu1 by v. It should be equal to mu2 minus mu1 by r1 plus mu1 minus mu2 by r2. I'm just adding, okay? I'm not doing anything here. So you can see these two will cancel here. So leaving mu1 by v, let me write this one, minus mu2 by u. This is equal to mu2 minus mu1. Here is mu1 minus mu2. These two are opposite here. So on the right hand side, let me take this common. mu2 minus mu1 is taken common. If you take it common, you have 1 by r1. Since there is opposition, mu2 minus mu1, and here is mu1 minus mu2, because of this, when you take mu2 minus mu1 common, this plus will change into minus 1 by r2 here. Then you transfer this, take this common, you can write 1 by v minus 1 by u is equal to, and this I think it should be mu1, yes, okay, so mu1. So you just take mu1 common from here and transfer here, divide this, so you have mu2 by mu1 minus mu1 by mu1, and keep in mind this mu1 comes from here. Just take common, mu1 take common and divide here, okay? Then you have 1 by r1 minus 1 by r2. But you know that this 1 by v minus 1 by f is, 1 by v minus 1 by u is nothing but your length formula here. So you can use it. So you can write 1 by f is equal to mu2 by mu1. So writing minus 1. It's okay. 1 by r1 minus 1 by r2 here. But you know that mu2 with respect to 1 is equal to mu2 by mu1. So if you use it here, you have 1 by f is equal to mu2 1 minus 1. Then you have 1 by r1 minus 1 by r2 again. Or simply this equation can be written as 1 by f is equal to mu minus 1, 1 by r1 minus 1 by r2 here. So this equation is what we call as the Lense-Makker's formula. This derivation is very important. Why is it called Lense-Makker's formula? Simply because this formula is used in making of lenses. For example, you can make a lens of desired focal length. For example, say if you want the focal length of some certain value, you can use this formula. And as you know, 1 by focal length is equal to power again, isn't it? So power is equal to, you can write u minus 1, 1 by r1 minus 1 by r2 here. For example, say you are going to wear a glass of, let's say, power 0.25 diopter, for example. You have to put in here, and you can take the glass material, let's say 1.5. Then accordingly, what you can make the lens. In simple language, this formula is used in making of lenses. That's why this is known as Lense-Makker's formula. So I just want you to go through it, the derivation, and I'll be sending you one assignment here based on what we have done before. So you try to finish up this assignment and try to send it to me by 10 p.m. tonight. Okay, in the first question here, you derive this one. Derive the expression for derive the expression for the refraction through a convex spherical surface when the object lies in the rarer medium. And second question, what is Lens-Maker's formula? Derive Lens-Maker's formula here. 1 by f is equal to mu minus 1 by r1 minus 1 by r2. So you try to answer this question and you send the answer to me, and I'll see how many of you are attending my class. Okay, then see you in the next class again.